Alright, this is the next question. So draw the isometric projection of a hexagonal prism 30 mm base edge and axis 50 mm long, resting on HP on its base with one of the base edges parallel to VP. That's your question. I want you to pause the video for a second and think about this, the position of the solid. Okay, hexagonal prism resting on HP on its base and one of the base edge parallel to VP. In which view you can see the hexagon. Okay, in the top view you see the hexagon, and the front view you see the sort of a rectangle. So the top view is sort of a hexagon, one of the base edge is parallel to VP. In the front view you see the rectangle, sort of the rectangle. Name the points A, B, C, D, E, F at the top plane. The bottom plane is A1, B1, C1, D1 and E1 and F1, the brackets, because the top that represents the bottom plane. The front view, this point is your A dash, B dash, C dash, D dash, E dash and F dash in brackets. The same thing happens the bottom side. A1 dash, B1 dash, C1 dash, D1 dash, D1 dash, E1 dash and F1 dash are in brackets. Okay, now what you're going to do is so that completes your first step. Okay, first step is draw the front view and top view of the solid in the given position, and the second step is whatever that is in the top view, insert that in a rectangle, just like this. Okay, so basically what you do is you put the hexagonal prism inside a box. So the top view of the box is what you see in the red line. Okay, so that's exactly what you do. So to draw the idea is you draw this box, the isometric projection of the box, and then inside the box you find out where these points A, B, C, D are touching the box. You connect those points. For example, A is touching here, B, C, D, E. Your hexagon forms the top plane, so it should come here. So you redraw, you find out these points in the box, you complete the drawing. It's as simple as that. That's what we're going to do. So I have completed up to this point. You can see it here. You have the top view of the hexagon and the front view of the hexagonal prism. And I have inserted the hexagon inside a rectangle and named it as 1, 2, 3, 4. I have also constructed a isometric scale so that in one side I have taken 15 degrees. I have drawn a line from one end. I have taken 15 degrees, drawn a line. At the other end I have taken 45 degrees, drawn another line. And this side represents my true length side, and this side represents my isometric length. If I want to find out the isometric length of 1, 2, all I have to do is take this distance, offset it here and draw a parallel line. That will give you my corresponding isometric length. Or else I can measure it using a scale and multiply. Using a scale I can measure it and multiply that distance by 0.816 using a calculator and measure it and complete the drawing. Okay, so I'll explain the second step once again. Whatever that's in the top view, insert that in a rectangle. Now what you are going to do is we are going to draw this rectangle at 30-30 angle. All right, so I'm going to show it right here. So a line like this, then take your protractor, 30 degrees, and then draw these lines. Okay, what I'm going to do is I'm going to draw these lines as a very feeble line. Still I think you can see this. Okay, I'm drawing just a bold line because I can't see it in the video. That's my 30-30 line. Then I have to measure, so I'm going to pivot this point as 1 here. So if you pivot the point 1 here, it's something like this. We have, let's say, you have a plane like this. This is your 1, 2, 3, 4. Pivot the point 1. You rotate. This is, you bring the plane to isometric position. This is what you get. This is 1, 2, 3, 4. 1, 2, 30 degrees, and 1, 4 also 30 degrees. So this 1, 2, 3, 4. This length is offsetted along this direction, but we can't straight away take 1, 2 distance and offset it here. Why? Because we have to account for the foreshortening, and that is what exactly I am. So what I'm going to do is I'm going to show it graphically here. Okay, I'm going to take this distance from this point, and offset the distance, and then I have to draw a parallel line. How do you draw a parallel line? All right, keep it like this, slide it over, and there goes your parallel. All right, that is 1, 2. I'm going to take 2, 3 also, 2, 3 also, 2, 3. So I get the isometric length, corresponding isometric length here. Or else what I'm going to do is I'm going to measure this as 6.2. 1.2 is actually 6.2 into 0.816 equals 5.05. I'll take it as 5.1. Okay, so I'm going to just make sure my 1.2 is at least 5.1. See, it's 5.1. 5.1. So this, measure this distance and you multiply that by 0.816, you'll get the same distance in the isometric scale. And which one, you can choose any one, doesn't matter. If you are not drawing the isometric scale, you have to show this true length, iso length by true length is equal to 0.816. It's always better to draw the isometric scale. Okay, so if you don't have enough time or you're running out of time, you can always use the calculator and work out the calculations. So this is 1, 2 distance. I'm going to take this 1, 2 distance, right, and offset it here. So 2, 3 corresponding distance is this. As you can see, this 2, 3. 2, 3 distance is this. And 2, 3 is same as 1, 4, so that's why I'm taking this as 1, 4. So 1, 4 is same as 2, 3. So I've taken that distance. So that's my 4, and this is 1, 2. So to complete this, what I'm going to do is, take this distance from here, cut an arc from here, take this distance, cut an arc. You have to rub off unwanted lines. You can't do that because you're drawing using a pen. Now to complete the box, remember you have to draw the box. This length is 1, 2, 3, 4. That's the top plane, right? How about this one? Where do you get this length from? This length is always obtained from the elevation, from the front view. So the length and breadth of the box, the base side of the box is obtained from the top view, whereas the height is obtained from the front view. That is, you don't need to measure it because it's 50 mm. Now I'm going to make it an easy choice here. 50 into 0.816 equals 40.8. I'm going to take 40.8 distance. Just make sure all the measurements are same. Okay, and this is a little short. Maybe I've taken the wrong measurement. So I complete the box. I've completed the box. Now the next thing is, we need to find out. So this is 3, 4. Inside the box we have our hexagonal prism. You need to find out the points of A, B, C, D of the hexagon, A, B, C, D points inside the box. So the solid is resting on its base. So probably it's very sure that your top plane or the hexagon comes in the top plane of the box. So how do you find out point A? Point A is very simple. It's located in 1, 4. 1, 4 is right here. So what should I do? Straight away take this distance and offset it here, right? No, wrong. That's a common mistake most of the students make. Before offsetting the distance, you have to find out what? The corresponding isometric length. So for each time, you have to find out the isometric length, right? That's your point A. A is actually on 1, 4, and we have taken this distance, find out the corresponding isometric length, and find out and offset it here, right? So that's actually the midpoint of this thing. So it's not a big deal to find out A also. Okay, if you can find out a pattern or anything like that, it's more easy to finish the drawing. Now you tell me, how many dimensions should I take to find out or draw the hexagon in this plane? Should I take each and every distance, or do you find out any pattern here? Now when I look at this picture, the distance from 2 to C is the same as 3 to E, it's the same as this one, it's the same as this one, right? And the distance from 1 to A is the same as 2 to D. So if this is the distance for A, this should be the distance for D. So that's my D. I'm going to make it as, this is A and this is D. Now, how to find out B, C, E and F? BC is lying in 1, 2. This is your 1, 2 line. So take this distance, find the corresponding, take this distance, find the corresponding isometric length. So from 1 to 2, from 1 it offset this distance, from 2 backside. Similarly 3E, from 3 to E, and from 4 to the side. So that's your B, C, D, E, and F. And connect those points to get the hexagon. That's your hexagon. Now, how do you complete this thing? Normally what you do is, if you go the other way, you have to construct a hexagon in the bottom plane also and connect those points. But here, you have a very simple solution. I have a shortcut for you. Now these planes, your left plane, right plane, and top plane are the visible ones. So all the other, so edges coming from those planes will be visible. So what I'm going to do is, I'm going to draw straight lines like this till we get to the bottom edge, bottom of the box. And then I'm going to connect these 2 points and these 2 points. Oh, just missed one. So to complete that, I have to complete. So if you draw a line from F, it should come where? Somewhere here. So I'm going to take this distance, offset to this side, and from F also I'm going to draw a line till I get to this point. Okay, that's my hexagon. Hexagonal prism isometric projection. So if you want, you can very neatly draw isometric projection. Right? I want you to try this at home using your scale and pencil.